Computer architecture. Computer architecture is the organization of the components which make a computer system and the meaning of the operations which guide its function. It defines what is seen on the machine interface, which is targeted by programming languages and their compilers. Examples of computer architectures are x86 made by Intel and AMD, the SPARC made by Sun Microsystem and others, the PowerPC made by Apple, IBM and Motorola. First one is control unit. Control unit means directs the operations of the computer is called control unit, and then arithmetic and logic unit means the operations of the computer. Both control unit and arithmetic logic unit is connected between the CPU, and then control unit and arithmetic logic unit is linked to memory. Memory is to store and retrieve data information, and then control unit is linked between output device in and input devices. Output devices are monitor, printer, that's our output devices, and then input devices are keyboard, mouse, etc. And then control unit is linked to external storage. External storage means in hardware and software to store the informations temporarily is a external storage. And then next one is ALU. ALU means operands of the computer, or flip-flop. Flip-flop means zeros or one operands. And then register files means to store the information. It means multiple files are stored in a single register. It's called register files. And then cache. Cache is nothing but to store the data. That is 0 or 1 is cache. Main memory. Main memory is to store and data and retrieve the information from the main memory. And then future Spintronics non-volatile devices plus CMOS power getting. Non-volatile devices are hard disk, floppy disk and disk drive, and then volatile devices are to store the data, that is non-volatile STT, M or AM. Next one is generations of the computer architecture that are used. In first generation 1945 to 54, and then technologies used in vacuum tubes and relay memories, and then software is used in first generation is machine language, that is ones and zeros. Examples are ENIAC, and then second language is 1955 to 64, and the technologies used in transistors, and softwares are Fortran. Examples IBM 7090, and then third generation is 1965 to 74. Technologies used in MSI, that is medium scale and integration, pipelining, cache, and then software is used in time sharing, parallel processing. Examples are PDP-8, IBM 370. And then fourth generation is 1975 to 90, VLSI, that is very large scale integration, vectorization, multi-computers. And then software is multiprocessor OS, compiler environments for parallel processing. And then examples of examples of fourth generation is SunSPARC, Cray, XMP. And the final one is fifth generation 1991 to now, and the technologies used in ULSI, ultra large scale integration, and the software is massively parallel processing. And then examples of final fifth generation is Crazy, Emot, CM2.